Yes, Emily.
About the last one, never mind. Yeah, never mind.
The name of this?
Yeah.
1-methyl-3-chlorobenzene. Maybe 1-chloro to alphabetize, 1-chloro-3-methylbenzene, something like that.
Another question, there was something else.
Usually though, okay, while I came back to it, usually you would name that thing with toluene as the parent. So to call it methylbenzene is pretty inaccurate. People don't do that. They recognize the methyl on the benzene, they call it toluene. Emily, do you remember what you were going to ask? Or what it was?
I remember it was
You want to ask it?
no.
Okay. All right, that's fine. You read about these. Ortho, meta, para. This only applies to aromatics with the benzene ring. You have to remember, we usually don't use a numbering system. It is only when there's 2 functional groups on the benzene ring. So this is very specific, and it's just one of those things you remember when you do organic chem. People think because I'm a chemistry teacher, like I'll tell people, oh, I'm a chemistry teacher, and they have this perception, oh, wow, you're really smart. And even some of you, especially those of you that haven't had me for a year, you might think, oh, Mr. Moore's an advanced chemistry teacher, that guy's really smart. Let me just set the record straight. I'm pretty stupid. You'll find that out. As the year goes on, I'm going to get dumber and dumber all year. And I was always that dumb. It's just that you had a different perception. Okay? So I'll just get it out of the way. Now, I'm going to admit, even now, I would look at this and say, okay, para, they're on opposite sides, like in the 1-4 position. Meta is in the 1-3 position. Ortho is in the 1-2 position. Okay, fine. I'll walk away from it. And if you ask me that a couple minutes from now, I think, which one was the ortho? Which one was the meta? I can't remember. And I don't. My memory is pretty bad. I got a bad memory. If I don't come up with some kind of memory trick to remember this with, I'm done. I won't get it right. So I have taught myself when I need to memorize something like this, and I don't know, I can't remember the opposite sides of para. So I train my brain to remember things by using associations or whatever. So when I have a memory trick that I can help you remember something with, I'll share it. Sometimes what I have in my brain is not appropriate, only for me to think about, so I won't share everything with you. But the more you use your imagination and maybe come up with zany things, the better you can remember. Here's what I think, and this has helped me for years, and I'll never get this wrong because I have this. Brute force memory, I can't do it. I think of the 2 functional groups on the benzene ring as a relationship between 2 people. Now stay with me. At this point, this is the very beginning when these 2 they're on opposite, they're kind of going the opposite way. They don't even know each other yet. I would say they're a pair of strangers.
Oh.
They're a pair of strangers. Now at this point, they're a little closer. At this point, they've just met. Oh, baby, they're close now. So I'll think of that, and now I've got it. I can remember. I look at that thing and I think, okay, there's a pair of strangers. And so, they've just met and, oh, baby, they're close. And so memory tricks can be a wonderful thing, especially in a class like this. Sometimes when you have to remember factoids, if you can associate things with them, even if they're not for other people to hear about and they're only in your brain, it works. Okay. We're not going to do this because you already know. Your brains are much better at remembering than mine is. So you'll know how to name those things, and we're good. I have had people, though, write me emails and say, hey, we're just in my organic class, and the teacher was talking about the functional groups on benzene. I remember what you taught us about a pair of strangers and all that. And so that's kind of fun to think that people still remember. Okay, so I think we're good. Yeah, the benzene can be a functional group. It's a phenyl group. That was on our... something like this. You should be able to name that. I would not try to assume that the benzene is the parent in this compound. Even even in spite of the fact that it's on top, kind of, and arranged to look like a functional group, it definitely is, because I don't know what this functional group, if benzene is the parent, what do you call the rest of that thing? I don't know. So, yeah, if it looks like it's easier to name the benzene ring as a functional, then just use phenol. Yes?
So hexyl isn't a thing?
Hexyl could be a thing if it were on the end carbon. If you got the benzene ring coming off of there, you'd call that hexyl benzene. But it's on the third carbon of the hexane chain, so. I'm not even going to try to name, I don't know what you call that thing. If it's not 3-phenyl hexane. Anybody have any questions about that? That's our benzene lesson. Okay, I'm going to go back now to, got one other type of reaction. I got, what, 8 minutes to do it in. Oh, sorry that this is taking so long. Okay, another class of compounds. Oh, well, before we get to esters, this is the last type of reaction that I'm going to teach you, the condensation reaction. So what have we learned? We've learned substitution, addition, oxidation. And from oxidation, we get several different types of compounds out of it. And then we're going to get several more different types of compounds out of condensation reactions. Now, condensation probably has something to do with condensing. In chemistry, we think, oh, condense, that's when a gas becomes a liquid. And that's true. That is not what this is about, though. What else might condense mean? To get smaller. To get smaller. And what is always going to happen with a condensation reaction is you're going to have two reactants, two organic reactants. They're going to join together, but they're not going to join together and have the same mass as before because they're going to lose a molecule. And I'll show you what I mean. There it is right there. There's the molecule that gets lost, the water molecule. So you're going to lose a small molecule when a condensation reaction happens. Probably my favorite lab in all of my experience in chemistry was making esters. I'll just go ahead and show you the pattern for these things, but then we'll get into what esters are like. Hey, nobody in here, I've asked you this already, nobody's had the organic semester class, right? When you take the organic semester class, you'll make esters, and you'll always remember it. It's really, really fun and interesting. But you'll start with an acid. And we just learned about these yesterday. The acid has the C double bond O OH on the end. What's the name of that thing?
That's it.
Yes, ethanoic acid. Yeah, ethanoic acid. You got the eth, two carbons, and then the ethanoic in the name. Okay, what's the name of this thing? Ethanol. Yep, another eth because it's two carbons. Ethanol. Do you need to call it one ethanol?
No.
No, because it doesn't matter which carbon it's on, it's going to be one. When an acid and an alcohol are allowed to react with each other, now you do have to heat this mixture up. So you measure out some acid, put it in a flask, measure out some alcohol, put it in a flask, and then you heat it. And you heat it for about a half hour. And over time, this ester connection is made. The acid is going to wind up losing an OH. So it's got the double bond O and OH on it. The OH comes off. The H comes off of the alcohol. So there's where our water molecule is from. There it is right there. I color-coded it so you can kind of see where the water molecule comes from. And then what's left of the acid joins up with the oxygen on what's left of the alcohol. And this part right here is what makes this compound an ester. We don't need to name esters. They're not hard to name, but we're just not going to do it. We don't have that much time. Acids in organic chemistry, organic acids, almost all of them have a bad smell. They are pungent. They can make your eyes water. They'll make your nose shrivel. They're not nice to smell. So just about any acid that you start with, the worst of all is butyric acid. Sometimes the organic class is using butyric acid, and the whole school will smell. It smells like vomit. It's very unpleasant. You know what vomit smells like. It's gross. Alcohols, typically they don't smell so bad. I love the smell of most alcohol. I was passing around the rubbing alcohol. I love it.
Sounds like you're just buzzing up.
No, that's on recorded too. When you heat these two up, remember this thing was totally nasty. Heat these up, and after 20 minutes, half hour, it smells like bananas, or it smells like apples. Esters are the compounds. Literally, these are the compounds that are in fruits that give fruits their fragrances. And they're made from these, like these are nasty, gross things. But when you combine it with the alcohol and it makes that ester connection, the smell completely changes. And you know how I am about smelling even by now. Second weekend of the course, you're like, this guy's a freak about smelling stuff. Well, that was my favorite thing. We would go from one station to another. The teacher had us making all different esters. You got bananas, apples, peaches, vanilla. It was so much fun. It's really cool. So you'll be able to do that when you do the organic class, if you have the chance to. I do recommend that. So that's what an ester is. Just know, again, we're not naming this ester. Just know that when you have the C double bond O and an O in the middle, you're going to have carbons on both sides of that connection. That's an ester connection. Does anybody know any words that have ester in them? That, yes, polyester. Polyester, we're going to learn about tomorrow, is a polymer where you have a molecule that has many ester connections in it. It's like all these repeating units in it. That's what a polymer is. And so we'll see that. Polyester compounds. Okay, they just have time for one more, hopefully. This one is, the name of it you won't recognize. Another condensation reaction is called an amide. Sometimes it goes by a different name, though, that you will recognize, but we'll talk about that in a moment. You see an unusual term in there, that R. What's that? R looks like it's dropped in from nowhere. R is actually used a lot in organic chemistry. It's only in organic chemistry that we use the R. And the R is there to just represent some arbitrary carbon chain. So whatever the parent is, we call it R. I don't know where they got R. It's probably from French. But there it is. And so an amine compound is some organic chain that has an NH2 on it. NH2 would be another functional group. It's an amine group. This compound's an amine. It will react with an acid. We know how an acid looks. It has the C double bond OOH. And when those two combine, it's a very similar reaction to what we just saw. Here it is. We have ethylamine. You got the two carbons. There's our ethyl and then the amine on it, ethylamine. And this is ethanoic acid again. This is like... It's going to ring in one second. Oh, man, I'm really sorry about that. So we'll pick up on this tomorrow. And I'm not even going to breathe tomorrow. I'm just going to take a deep breath and start talking and not stop till 2:09. All right, my friends, have a nice Thursday. Friday Eve.